Everyone thinks the AI war is about chips, NVIDIA, GPUs, supercomputers, giant data centers. That's the story we have been told. America builds the most advanced AI chips. China tries to catch up. Billions gets invested. Government panic. Tech companies race to build larger and larger AI systems. But underneath all of this, there is a tiny material almost nobody talks about. A material so obscure that 2 years ago, most politicians have never even heard its name. And now, it may be one of the biggest bottlenecks in the entire AI race. Not because it powers AI directly, but because without it, the machines can't properly communicate with each other. And the country controlling that bottleneck is not the country most people would expect. Right now, companies are building AI infrastructure at a historic scale. Not just bigger servers, entire AI cities, massive facilities packed with tens of thousands of GPUs running simultaneously. And here is the important part. Modern AI no longer depends only on how powerful each chip is. It depends on how fast thousands of those chips can talk to each other. That changes everything. Because eventually, the real problem becomes traffic. Imagine trying to coordinate hundreds of thousands of people in real time. If communication slows down, the whole system slows down. That's exactly what is happening inside modern AI data centers. And this is where hidden problem appears. For years, copper cables connected servers inside data centers. Okay, because they were simple, reliable, and cheap. But AI systems became so large, the amount of data moving between GPU exploded. And it exploded so fast that copper started failing. Too much heat, too much power loss, too much signal degradation. Physics itself became the limit. So the industry turned to something else. Light fiber optics. Instead of electrical signals, AI systems now use laser to move information between machines at incredible speeds. And those lasers requires a very specific material, a material called indium phosphide. Most people have never heard of it. But suddenly, this obscure semiconductor material became so essential to the future of AI infrastructure. Without it, advanced optical communication inside AI clusters become dramatically harder. And this is where the story becomes geopolitical. Indium phosphide sounds futuristic, but the strange part is how it's actually produced. It doesn't come from some rare futuristic mine. It is mostly extracted as a side product from zinc refining. That means the world cannot easily scale production whenever it wants. Even if AI demand explodes overnight, supply cannot instantly respond. And then comes the bigger problem. The global supply chain is incredibly concentrated. A huge share of refined indium comes from China. The wafer manufacturing is dominated by only a handful of Asian companies. Not dozens, not hundreds, just a very few. Which means one obscure material inside one obscure industrial chain suddenly gained enormous strategic importance. And Beijing, as always, noticed. In 2025, China introduced export controls on several critical minerals. Most headlines focused on rare earths because, but buried inside those restrictions was something far more important for the future of AI infrastructure. Controls tied to indium phosphide. Now every shipment requires approval. Every buyer gets monitored. Every export request creates visibility into who depends on that material and how much they need. And this is where the balance of power quietly shifts. Because the country building the most AI infrastructure is not the one necessarily controlling the supply chain underneath it. That's the hidden vulnerability. America dominates advanced AI chips, but China still holds leverage deeper in the industrial chain. And leverage inside supply chain can become geopolitical power. At first glance, this sounds like a niche industrial issue, but it's not. Because AI capability increasingly depends on scale. Larger AI clusters, more GPUs, more communication between machines. And the larger cluster becomes, the more important optical communication becomes. Which means this tiny material now sits underneath the entire AI expansion. Suddenly, the timeline for building next generation AI infrastructure may partially depend on export license approved in Beijing. That changes the conversation completely. The AI race stops looking like, who has the best AI model. Okay, so it will basically stops there, and it will start looking like who actually control those industrial foundation underneath those models. That's the much deeper competition, and this is the part most people miss. The AI race is not just a software race anymore. It is not even just a cheap race anymore. It's becoming a resource war, a manufacturing war, a supply chain war. Future of artificial intelligence may depend less on algorithms and more on obscure industrial materials hidden deep inside those global trade networks. And that changes how power works in modern world. Because geopolitical influence no longer comes only from armies or oil. Sometimes it comes from controlling the tiny invisible component the digital world cannot function without. So, when people talk about the AI race, most imagine futuristic robots, giant models, billion-dollar chips. But underneath all of that, the real bottleneck may be material most people have never even heard of. A material refined through a fragile supply chain, processed mostly in Asia, and increasingly sitting at the center of global power politics. And if that supply chain tightens further, the country deciding how fast AI develops may not be the country leading the AI race itself. It may be the country controlling the hidden layers underneath it. That's what makes the story so important.